All right, on our next stop on our tour, we had to put our safety goggles on. It is loud in here. There's a lot going on in here. So Henry, kind of walk us through, talk a little bit over the noise of what is going on exactly here in the workshop.
Yeah, so we're here in our mechanical subgroup, and we're all hands on deck at this point, working on a lot of different subsystems. We've got our intake, our shooter, and elevator going, as well as manufacturing some parts for our chassis. So it's everything kind of moving at once. So Ria's going to kind of walk you guys through all that's going on in here and what the end goal is.
Maybe show us what we're working with over here.
So this is the base of our chassis here, and we're working on getting the base of our elevator mounted currently. Our elevator consists of 2 stages. So this is our inner stage, and this is our middle stage. It is motored. So there's a pivot point here that our shooter would mount onto, and it's motored by 125 to 1 stage gearbox. And then we'll have an elevator pivot down below near the bottom of the chassis.
Ria, tell us what we're looking at here.
So this is our shooter. While prototyping, what we learned worked best was having a middle wheel, which I know a lot of teams disagreed with that. And we might be wrong. We might just take this wheel out later. But as of right now, what we saw was it helped make the shots more predictable because it applied force in a very consistent way. It kind of pulled it apart like a rubber band, and then when it released it, it was only this wheel releasing it, so we knew it would go in the same direction almost 90% of the time. And then we have 2 feeder rollers or guiding rollers back here. Eventually what we'll have is a one-way bearing on this roller, not this one, the front one. So when the node does engage in our big wheels to shoot out, there won't be a tug of war between these two, pulling the node apart in 2 different directions. So that's what we're trying to do with our guides. And eventually we'll have a polycarb plate just to hold the node in place. We're using the shooter both for amp scoring and for speaker scoring. As we program it, we'll have our elevator go up, and then our pivot would pivot down, and we'd release slowly into the amp. So hopefully this mechanism works for the trap as well. It does in the CAD model. Now we just need to test it in real life to make sure it does.
What are we looking at here?
So these are pieces of our intake. We are just taking apart our prototype for our intake that we had going, just so we can start assembling our actual competition intake. We are going for an underneath the bumper intake, so our intake is within our frame perimeter. So these are our cross beams that would go in front of our intake and what our intake side plates would mount to. But what they're working on back there is our intake side plates. So we have 2 polycarb rollers with some silicone wrap on top. So what we learned is this diameter tubing works really great, and you can have it really close to the ground, and it picks it up. It's very touch it own it. We did lower our chassis rails so that notes don't get stuck in as we're driving over, but it's pretty consistent. We had to manufacture a lot of the parts for this in-house, so we had to 3D print a lot of these inserts that also act as pulleys. We have spacers inside the polycarb rollers to help with bending and flexing as these go. We had a lot of trial and errors this week with the intake. We had to switch rods, we had to switch bearings, just because steel bearings and aluminum rods don't mix well. This is kind of what it looks like at an angle. This is our gearbox, once again, manufactured in-house, 3D printed. We don't have our climber put together, but our climber and our elevator are 2 separate pieces. Our elevator is what we'll use for scoring, and our climber is what we will use to actually get ourselves on top of the chain. These will be at the edge of our chassis, and we will have a winch powered by 2 Falcons at a 25-to-1 gear ratio that would pull the chain down to our bumper. And that's what we figured would be the easiest to score into the trap. Getting the chain down to your bumper is your best bet at doing that. So yeah, that's our climbing mechanism right there.
So you walked us through all the different sections of building your robot. What do you feel personally is the most challenging creation, or what's the most challenging station in bringing this robot to life and having it find success in competition?
So intakes and elevators obviously are something our team has been doing for years. You know, we've got that figured out pretty much. Like obviously the game pieces change. You know, you need to modify each of those designs. Elevators are something our team has not done in recent years. It's like a lot of uncharted territory. We tried chains last year. We found great success with it. So we are incorporating chains into our elevator system. But it's a lot of, you know, we've never designed something like this before. So CAD took a long time. We've never built something like this before. So there's a lot of, you know, trial and error, finding mistakes, fixing those mistakes. So definitely the elevator.
Thank you for taking us on this tour. This workshop is all the magic happens. It's really cool. So thank you so much, Rue.